Hey everybody, welcome back to Young Engineers of Today, the Science Olympiad uh, spinoff, I guess. Anyway, I apologize for being late. Ran over a couple of minutes in my previous class. I have one that ends literally right before this one. Everybody had tons of questions, but that's how it goes. It stands now though. I'll run a few minutes after 9 if you guys would like, obviously, and we can do question and answer for you know for a good long time afterwards as well. Thank you, Naomi. So when we first met on Tuesday, we spent some time talking about what Arduinos are. They're basically miniaturized versions of things that go into factories, meant for more hobbyist use. And they are, you can think of them like computers, but they're very stripped down. They don't interface with keyboards or monitors or anything like that. They have their own specialized programming language. And their entire purpose mainly is to sort of be the brains of a more complex setup, or to be the brains of a more complex machine made up of smaller machines, that sort of thing. Or mechanisms or something like that, anything like that. But that's basically the purpose. It's meant to control the flow of, input and output so that it does something intelligent. In the case of like factories, regulate the temperature and the power consumption and the cooling and everything like that of everything. And the example I was using on Tuesday, you can make something that listens for your listens for an app, like a signal from an app on your phone, and locks your door. You can use them for quadcopters, 3D printers, just a whole bunch of different things. And that's really what they're meant for. Is they're meant to really sort of expand upon the possibilities of hobby work. Spend some time talking about the hardware, just all the things that exist on the Arduino. You've got a power jack, obviously, a barrel plug, which provides it with all its power. USB, when it's plugged into your computer, you can provide it with power through there. Power pins, when it's just running normally, you can have power pins providing power to it. Also, you can have power pins providing power out to your electronics that are hooked up to the Arduino. Analog and digital pins, which are your general purpose input and output pins, or GPIO pins, which you can use to take in signals or send out signals. Even on the same pin, you can have one circuit hooked up that sends signals into pin 13. Then you can, disassemble all of that and hook up a new circuit and write some new code for the Arduino and have it send stuff out on 13. Now, granted, you can't really have it take in stuff and send out stuff on the same pin in the same program, but from program to program, you can change whether or not it's an input or an output pin, and that's the nice thing about those is it can go either way. Got a reset button, highly technical. Transmitting LED. Oh, yep, sorry about that. Transmitting LED and receiving LED, just to let you know when the Arduino is communicating with your computer via USB, and that's strictly what that's for. And a pin 13 LED, excuse me, coughing fits. Pin 13 LED to let you know when pin 13 is on. And again, that's very useful for debugging purposes, to let you know whether or not the Arduino is sending or receiving information on that pin. So you can narrow it down to either being the Arduino or the circuit being the source of your problems if you're running into an issue. We've got the power on LED. Very important thing, lets you know when the Arduino's on. I can't tell you how many times I've seen people or had it happen to myself where they're like, this isn't working, and then they don't realize that it's because their Arduino is not on. You'd be surprised. We talked about breadboards, and we've got the horizontal rails and the vertical rails, or buses. Remember, the horizontal buses are in the middle, and they don't go over the exact, like, the very middle, but they're in the middle area. But that's how you can connect two things onto the same circuit, is you can hook them up on the same bus. Same with the vertical bus. The vertical bus runs from top to bottom, though, for each of these, meaning that you can create common ground and common power sort of rails. It is also important to note that for that reason, you want to make sure that any component that you have is going to be hooked up on two separate buses, because if it's hooked up on the same bus, it will either not draw power, or the power will complete there and not go all the way through, and either way you got a short circuit and it's bad times. We talked a little bit about electronics, LEDs. Remember, LEDs have polarity, so it's important to plug them in a specific way. You've got the anode, which is the longer leg, and the cathode, which is the shorter leg. And you want to make sure that the anode is plugged in towards the back of the circuit and the cathode is plugged in towards the front of the circuit. So electricity runs from the anode to the cathode and out the other direction. Because remember, LEDs are light-emitting diodes, and diodes are essentially one-way streets for electricity. Resistors, however, don't really care. Resistors can go either way. You can have resistors hooked up to, one way, and then you can pull them out and flip them around the other way, and they don't care. Their entire purpose is to turn electricity into heat, so they're pretty easy going. Then we were going to build our first very simple circuit using 123D circuits, or circuits.io, because it's circuits.io more recently. But yes. Let me go ahead and get that opened up right now. Circuits.io. Hopefully you guys are still logged in from your earlier session. If not, go ahead and log in now. And I'm going to go ahead and create a new circuit. You don't have to. You can use the circuit that, if you worked alongside me on Tuesday, when I was just sort of showing off how to like the last 2 minutes or whatever, when I was showing 123D circuits, you can use that. If you don't have that, though, that's fine. You can build one from scratch alongside me. So I'm going to go ahead and go up to Create. This is tab here labeled Create. I'm going to click on Open Electronics Lab Hub, because that's the one we're going to be working with. I've got a whole bunch of circuits because for multiple projects and everything like that. But what I'm going to do is I'm going to click on New Electronics Lab. Just a nice big green button. And with that done, I've got a nice breadboard, a digital breadboard. Look at that thing. Okay, so what we're going to do is we're going to hook up an Arduino to an LED and a resistor and make that LED blink. So let me go ahead and zoom out a little bit and run through the controls for 123D circuits, or circuits.io. I'm going to use those quite possibly interchangeably, although I am really trying to use circuits.io now since they have a more definitive name. Okay, so you can use your mouse wheel to scroll in and out. I believe you can, no, you cannot. Well, at any rate, you can use a mouse wheel to scroll in and out. You can also click and drag with your left mouse button or your right mouse button to pan. Just make sure you're not clicking and dragging on a component. If you have a blue outline around something, then you're moving that thing around. If you don't have a blue outline around anything, then that means you're moving your view around. Left click on something in order to select it. You can tell it's selected A because of the blue outline. So let me zoom in. Blue outline. And B because you'll have a little info board up here in the upper right-hand side with some stuff that you can change about it. Ah, yes. That's an excellent point. You can click this little button here. If you mouse over it, it says zoom to fit. Click on that, and it will fit everything that you've placed down on your screen. So you can, make sure that you're seeing everything at once. Thank you. Excellent point. But yes, so this info panel over here, you can change information on it. This is contextual, so it's going to be different based on whatever you have selected. In this case, since it's the breadboard, really all I can do is change the name the change. Geez. We're just going to call this breadboard. Or just B, apparently, because my computer's going to hang up. There we go. Breadboard. Spelled excellently. But yes, so like I said, that's a contextual thing that's going to change based on what you have selected. Now, another thing you can do is you can select an item and you can hit the R key on your keyboard in order to rotate it. If you hold down the Shift key and hit R, you'll rotate it in the other direction. So clockwise, counterclockwise. I'm going to go ahead and rotate it vertical for this thing that we're building. Bam. Now we've got our breadboard. Now, as you can see, if I mouse over the individual sort of slots, I get a little red square and some green lines. Green lines denote what else this particular slot is connected to, what's on the same bus as it. So if I mouse over this one, I can see just these other four are on the same bus as this one. Whichever one I have my cursor currently on is going to have this nice red and black square. It's just unmistakable. And if I click there, I can draw jumper wires, which we can then use to connect to other stuff. And I can draw a sweet racetrack. You can also hit the delete key to get rid of anything, because that was a totally useless set of jumpers. Or jumper wire. Anyway, what we need to do right now is we need to have other stuff here than just a breadboard, because a breadboard doesn't really do anything on its own. It's kind of boring. So I'm going to go over here to the Components tab. As you can see on the right-hand side, we've got Code Editor, we've got Components, and we've got Start Simulation. So these three buttons here are going to be buttons that you're going to get very familiar with by the time we're done. I'm going to click on Components, and bam, this little tray pops up down here. It's got a list of all different kinds of components that we can use. All different kinds of components we can use, and we can just simply click and drag this stuff out in order to use it. So what I'm going to do is I'm going to drag out a resistor, because remember, our simple circuit is going to involve a resistor and an LED and a power source. I'll drag in an LED as well. Those should be the first two things listed, which is pretty simple. If you're looking for a specific type of resistor, don't worry about it. Just drag out the generic resistor and you'll see why in a minute. But yeah, so we've got an LED and we've got a resistor and we need our Arduino. Now, there's a whole bunch of stuff here. We can go searching through this, or we can make our life easier. At the top of the components tray, the top right, there is a search bar. And if I just type in Arduino, we've got a whole bunch of stuff that pops up. For some reason, a polarized capacitor. No idea why, because Arduino is not contained within that at all. But we do have an Arduino Uno R3. That's the one we're interested in. So go ahead and drag this one out as well. And as you can see, once it comes out, it's a pretty decent size. But this is going to be what we're working with in addition to our LED and our resistor. So I'm going to go ahead and click the components button up here in order to put that components tray away again. And these are the three things we're going to need for our circuit. Now, let me go ahead and go back and review what exactly these components are going to be. So we've got our LED, color of our choice, and we've got a 330 ohm resistor. These are the two things we're going to need in our first circuit. Well, how do we know what that is? What if that's not a 330 ohm? Well, no problem. I can just go ahead and click on it so it's selected, as you can see. And over here in the contextual menu, little contextual panel here, it's got a name and it's got a resistance value. And we can change that resistance value. So I'm going to go ahead and type in 330 and change the little drop down to just regular ohms. Bam. And as you can see, the color bands on it changed color as well to reflect the fact that it's a 330 ohm resistor. So now we've got our 330 ohm resistor, we've got our LED, and in fact if I click on that I can change the color of the LED as well if I was so inclined. Just have a nice green LED. And these are all the components we need. So now we need to hook everything up to one another. If you mouse over the individual feet on the LED, you can see that they're labeled. One's labeled cathode and one's labeled anode. Let's go back and check our diagram again. As you can see, electricity runs from the anode to the cathode. And that is that's the orientation we need to set up our LED in. Also, looking at this diagram, it's got the LED, then it's got the resistor, and then it's got the ground. So let's go ahead and set it up using that. Got the cathode and the anode. We'll rotate it this way. Hello. There we go. So now the cathode is here and the anode is here. And we'll put the resistor in. And I'm also going to rotate the Arduino. So I got something to work with here. So everything's oriented more nicely. Oh, excuse me. Now, you'll notice you've got the resistor, or use the R key on your keyboard and you'll be able to do that. And if you hold down Shift and then hit R, you can rotate it in the other direction. But yeah, that's how you rotate items. So, certainly, we've got our components all hooked up. Now let's go ahead and set up. We'll set up the ground rail since, I mean, that's just kind of a nice thing to have anyway. What I'm going to do is I'm going to pick one of these slots on the rail that's labeled with a minus sign. So if we look up here and zoom in, as you can see, this more inner vertical row is the one labeled with the minus sign. I'm just going to click that. And I'm going to start drawing a line out. This is a jumper cable wire. Now, if I orient it specifically like this, I get that blue line. That lets us know that it's perfectly horizontal, which is great. I'm going to go ahead and click once out in this empty white space, and I'm going to put a bend in the line. This is not, strictly speaking, necessary. However, it does make things look nicer. I'm going to do it again, create another bend, bam. So now I've got this green line that runs from the ground to the minus rail. And in order to more easily denote that it is a ground connection, I'm going to use the little contextual menu here. when I click on the jumper wire and make it black. And that's because that's just sort of a standard. It's not quite, well, it is sort of a standard when working with electronics. The black wire tends to denote ground. Red wire tends to denote power. So that is to say, red wires are hot wires, brown wire or black wires are generally safer wires. This is going to be different with home wiring and stuff like that. For some reason, homes are really weird, and they'll use like green for ground and black for hot, which is not okay because that's very confusing compared to electronics. But by and large, when you're working with electronics, if you want to color code them, it's always good to stick to a standard. So what we could also do is we could have the 5-volt power hooked up to the power rail here. I'm actually going to skip doing that for now because our power is solely going to be provided by the pin 13 on the Arduino because we want to control when the LED turns on and off. So I'm going to go ahead and draw a connection right here. Straighten it out, and I'll make that one red. So that's a red connection. And as you can see, running from pin 13 to the same bus as the anode. And then I'm going to run a black wire from here to here, and that's just, whoops, it's got to be a black wire. Or excuse me, it's got to be onto the ground rail. So now it's on the ground rail. And this, for all intents and purposes, is a complete circuit. So we got power running from the Arduino, through the LED, through the resistor, through the jumper wire, through the rail, through the jumper wire, into the ground. Bam. So far, so good, right? In fact, if we wanted to, let me go ahead and just hook it up over here to the 5 volts so that when I can start the simulation, I can see whether or not it turns on. And in fact, it does, because the 5-volt power on the Arduino is just always going to provide power no matter what, forever and ever, amen. So that's good to know. If I hook it up to the 5-volt, providing a constant source of power, and the LED turns on, which means that this circuit is hooked up properly. However, like I said before, I'm interested in controlling when the LED turns on, which it does it automatically because it's already got some stuff uploaded to it. But we're going to figure out how to do that on our own. So let me go ahead, and I'm going to open up the Arduino programming IDE on my computer just so I can show you guys how that's done. So let me see here. Badoo. It's starting up, so it'll be just a moment. My computer is running incredibly slow. Okay, there we go. Because I can make the text super big in this one and it makes it easier for you guys to read. I'm going to copy and paste it over into the code editor for circuits.io though. Yeah. No, this is purely so that you guys can actually read what I'm typing, because I know it doesn't exactly come out super big on your guys' screen. On top of that, it gets compressed by the internet and then put into a smaller window than my own monitor anyway, unless you guys are running like a 50-inch monitor and you've got just like real size, which I would be jealous then. Not that my monitor is that big, but anyway, I'm getting sidetracked. Let me see here. Preferences. Editor font size. Oh, requires restart of Arduino. Let's just see how this is. Can you guys read that nonsense right there? Raise your hand if you are able to. All right, raise your hand if you'd like me to make the font larger. Okay, I'll go ahead and make it larger then. We'll go ahead and open the preferences, and we'll try 30. Oh, it didn't require a restart, but all right. That looks better. We'll go ahead and we'll give this a try because that's pretty dang big. So, programming in Arduino is the yin to the hardware yang. These two work together in harmony in order to create a fully working microcontroller and circuit and basically gizmo at the end of the day. A widget, a hoodad. Hoodad I don't think actually existed before my mind just decided to freak out and put two words together. But a hoodad. So anyway, these two things it's very important to get comfortable with both of them so you can have them work in concert. Now, if you're working in a larger group of people, you can have somebody who's definitely more comfortable with the coding thing and definitely somebody who's more comfortable with the hardware thing, and then they could work together in order to do what you want to do. But, if you're working on a project on your own, you definitely need to be confident or at least familiar with both aspects in order to make something from beginning to end. So to that end, this first project involves a little bit of hardware work and a little bit of software work, coding work. So the first tenet of Arduino programming is that there are two functions which always exist in an Arduino program. Always and forever will exist in an Arduino program, and Arduino will not run without these two functions. And that is void setup and void loop. Bam. These two things always need to be in an Arduino program, void setup and void loop, including all the punctuation that I put in there, the parentheses and the curly brackets and everything like that. If you do not have these, your Arduino will not run. And that is because that's just part of the programming language. It's like if you've ever messed around with, let's see here, Python, in order for it to work properly, commands that are inside of methods need to be indented relative to the method. In order to work with, and if you're using Java, you always need to have a class that contains a main function. If you're using, if you're using HTML, you need the brackets which denote the beginning and end of HTML. These are just things, pieces of structure that exist in the code that are immutable, and they cannot be, they're just part of the package. They cannot be excluded from the final program. Now, you can make it so that they're almost never used with some trickery. I mean, technically they'd still be used once per cycle, but or at least the void loop would be, but they still need to be there. Now, what are they, you might ask? Well, there are two sets of commands that an Arduino will always run whenever you boot it up. Void setup will always run once when you first provide power to an Arduino. It will always run once and only once, provided you don't hit the reset button or cut the power and put it back into the Arduino, or cut the power. So it will run void setup whenever it starts up. As soon as it is done with void setup, it will run void loop. Here's the thing. Void loop will run over and over and over and over and over and over and over again. It will never stop running for as long as the Arduino has power. Again, provided you don't hit the reset button. So the flow of an Arduino program can be thought of as thus. Let's just make this easier. Like that. And that's how an Arduino will continue to run for as long as it has power. Because an Arduino, the code in Arduino doesn't technically have a set endpoint, which can be a little confusing at first, especially if you're used to coding with something that, will eventually terminate and end. That's not the case here. It will not eventually terminate and end. At least it shouldn't. You might hang up, but it won't eventually terminate and end. So with that in mind, what are these for? Well, setup is generally for, setting up. You might tell the Arduino what, I don't know, what pins you're using. Your Arduino, your GoToWebinar might refuse to draw and might just totally hang up. I really hope this catches up. Anyway, you might tell the Arduino what pins are going to be input and output. You might tell the Arduino what sort of things it's going to be working with, like, oh, hey, so get prepared, we're going to be using a servo, and it's going to go, oh, hey, okay, like, we're going to be using a servo, thanks. Because the Arduino talks kind of weird. You might, define methods or variables or something like that. Well, you wouldn't really do that in void setup, but you might for later use. And just sort of that sort of kind of thing. And then void loop will generally contain the meat and potatoes of your program, where, raise your hand if you can still hear me. Okay, so my GoToWebinar is not responding, but it's still responding. I'm stuck in pen mode, so let me see if I can't make this work. Hey, total keyboard navigation now, because I don't have the ability to use my mouse. Excellent. But we'll go ahead and at least get this code set up. Pun intended. So here's the deal. These are functions. Functions or methods, depending upon your preferred nomenclature, are basically blocks of code that you can repeat on command, usually. Obviously, we have an exception here in void setup and void loop, where we do not have control over how many times these run. That was actually set in stone and tablets long ago in times of yore when the Arduino was but a thought in someone's mind. But by and large, we can create our own custom, functions later and call those at will. But just for now, know that that's what they're called. They're referred to as methods or functions. Normally, all your code needs to go inside of functions. Most of it. Most of the time. Normally. There are exceptions, though. In simpler programs, we can put some stuff outside of the functions. You can always do that, but it's generally more recommended for simpler programs just to make sure things don't get too out of hand. So I'm going to go ahead and I am going to, I'm really glad I have a hardware mute because I have to cough again. Oh, man. I'm going to create a variable, our first variable. Congratulations, your first variable. I'm going to call it LED pin, set it equal to 13. And why don't you guys go ahead and do the same? Because congratulations, this is your first expression in the Arduino programming language. Show of hands, how many of you have used something like C or Java before? All right. All right. That was actually a decent number of hands. Uh, you're going to feel not entirely at home, but oddly familiar with the Arduino programming language. It's actually very similar to a lot of the C family of languages. Now, Java has a lot of similarity to the C family as well, with some very glaring and notable exceptions, but by and large, the syntax can look decently similar. Similar enough, it's like reading, let's see here. We'll say Spanish and Portuguese. Um, you can get an idea of what you're reading, and if you're familiar with Spanish and you look at Portuguese, obviously there's going to be a lot of stuff that you're going to be like, I don't know what's going on there. Um, and there's going to be a lot of stuff you're like, I think it's like that. And then it actually, as it turns out, it's something different that has the same sort of look. But by and large, you're not going to be completely and totally lost compared to like as if you were just familiar with like, I don't know, Cyrillic, and you try to look at Portuguese and you just be like, what? So anyway, what we've done here is the first word is the word that denotes that this is an integer variable. So int is short for integer. It can only hold whole numbers. We are telling the Arduino that we are creating an integer variable. The second word is the name of the variable. This name of the variable is LED pin. Pretty straightforward, right? Just a lot like Java or C. Integer LED pin equals 13. Semicolon. Semicolon is like the period at the end of the sentence. Again, if you're familiar with Java or C, or JavaScript even, I believe, you will already be in the practice of putting semicolons at the end of your at the ends of your expressions, because it's just, you got to do it. It's like putting a period at the end of a sentence. So we've created an integer variable, we've called it LED pin, and we've set it equal to 13, and we've done it all in one line. Yeah, we just did so much with one line of code. Awesome. Now we need to do something with that, and we're going to do that in void setup. We're going to use our void setup for all of the setup of our circuit code, Arduino stuff. So what I'm going to do is I am going to use one singular line, pin mode. Notice how it's lowercase p, lowercase I, lowercase n, capital M, lowercase o, lowercase d, lowercase e, pin mode. This is referred to as Pascal case because the first letter of each word, if it's multiple words long, is capitalized. However, if it's just one word, and also the first word in a multiple word name, is all lowercase. So in this case, it's two words, pin mode, and all the letters in pin are lowercase, and just the M in mode is capitalized. So that's Pascal case. This makes it easier for you to be able to read the name of something. And it also looks pretty when everything has the same sort of uh, capitalization scheme. Granted, LED pin, LED is lowercase here, but that's just so it continues along with the convention. I can be kind of a stickler for this sort of stuff, and so I generally would like to keep it like capitalized, but in this case I have to fight against my urges and keep it lowercase so that it stays within the nice capitalization consistency. So pin mode, and then parentheses. In these parentheses, I'm going to say LED pin, and then input, all capital, output, all capitalized. Why do you think that was a mistake on my part? What do you think we're trying to do here? Yeah, exactly. We're trying to set the pin direction. Um, I'm sorry, I can't see the entire name because I can't actually expand the question window. But I'm going to guess to say James and not Jamie, I hope. Jim. Okay, Jim. That's easy. That's super easy. All right. Yeah, exactly, Jim. We're setting the pin direction. So if we were to take this apart, dissect this, we're setting the pin mode of something. What pin? Well, LED pin. What does that mean? Well, if we go up to just 2 lines, 3 lines before, we see the LED pin is 13. Replace that with 13. Bam, we're setting the pin mode for pin 13, comma, output. We're setting pin mode, we're setting pin 13 to be an output pin. That means it's going to be sending stuff out on it. Easy, right? It's just the syntax can be weird, but all in all, ain't that bad. So that's all we need to do in the setup. We've already set up everything that we need to set up. Bam, done. Now, loop is where all the magic is going to happen for our actual circuit. So what I'm going to do is I am going to, well, this is going to contain a few commands. We've got digital write. Notice how, again, I put the parentheses and the semicolon afterwards. That's because these are all function calls, and you'll get more familiar with what exactly that means in future lessons. But as it stands right now, digital write something. Well, we're going to put an LED pin and then high. Now, what do you think is going on here? Yeah, exactly. That's it. It's super easy. We're just turning the LED on. That's all. Jacob, perfect. Thank you very much. Thank you, Jacob. Yes, so that's all we're doing is we're turning on the LED pin, which by extension is turning on the LED because it's sending power through the pin, through the jumper cable, through the rail, through the LED, through the blah, 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 blah. You get the idea. So we're turning everything on. Well, we're done, right? But are we? We might be missing a couple of things. There's this one lesson that I want everybody to take away from this, from all of this, from everything forever when you're interacting with computers from here into perpetuity. There's this one thing, there's one little tidbit of knowledge that's always going to keep popping up again and again in your face anytime you're interacting with a computer on a base level, or you're coding with it, or you're working in IT or something like that. Yes, definitely, that's important. You always want to save. I'm thinking of something even more fundamental than that, though. It's the reason why you'd want to save. It's the reason why you'd want to double and triple check all your work. And here it is. Computers are dumb. They're super dumb. I love them, but they're dumb. They can do math like we can't even imagine. They can do all kinds of complex simulations and calculations and, permutations and alchemical formulations and, stuff like that. But they can only do what we tell them to do and no more. They cannot, absolutely cannot reason on their own. They cannot draw conclusions from abstract and disparate sets of data to arrive at a conclusion that may not seem related at first glance to all of these things. Like, I don't know, doctors can do in medicine. They cannot take vaguely similar groups of things and find clearly defined points where this group begins and ends. Like, I don't know, taxonomists. They cannot figure out why they're doing what they're doing and adjust their behavior accordingly, like, I don't know, philosophers or everybody. Computers can't do that. They cannot infer, they cannot assume, they cannot deduce. They cannot do any of that stuff. So when we tell a computer that it has to turn a pin on, we likewise have to tell the computer to turn it off. Because that computer was raised in a barn. It doesn't shut doors after it goes through them. In addition, how many times per second do you think this code is going to run? Yeah, fast times per second. Ballpark, thousands of times a second, hundreds of times a second at least. This means that this LED is going to be blinking faster than we can see. So we need to fix that as well. And we're going to do that by putting in a hard-coded delay. What we're asking the computer to do is to delay or wait this many milliseconds, or thousandths of a second. In this case, we're asking it to turn on, wait 1 second, turn off, and wait 1 more second. Then we reach the end of void loop. Because this is an Arduino and it's going to be stuck perpetually in void loop, it's going to go back to the top and it's going to say, okay, turn on, wait 1 second, turn off, wait 1 second, turn on, wait 1 second. You get the idea. So, what does this mean for us? This means, after all is said and done, our code is done. Hey, we've created our first blinking light. Look at that. It only took 12 lines of code. Well, 10 lines of code, really. And if you wanted to compress this even more, you probably could do, well, I don't know, 6 lines of code. I mean, whatever. You could do this in 1 line of code if you wanted to. That's the beauty of stuff like Arduino programming language and C and Java and stuff like that, is it is possible, if you were masochistic enough, you could create all of this in 1 line of code. I don't recommend it, though. I definitely do not recommend it, which is why I structured it like this, because it is very important to get into good practices with organizing your code and structuring your code so that you can read it more easily. Especially, let's say you take a break from this and you come back to it like a week or 2 later, you are going to be ruining the day you wrote this program if it's all in 1 line. In addition, you're also going to be really disappointed that you didn't put comments in it and stuff like that, but we're not going to cover comments today. We're going to cover comments at a later time in the future, because that's going to be another important thing for coding in general, and you might run into something in the Science Olympiad, like some bit of code to debug that has comments in it or something like that. Now, granted, you don't have to really have a complex understanding of coding to understand what a comment is, but it's just good to have. Anyway, what I'm going to do is I'm going to copy and paste all of this stuff, and I'm going to see if I can't find a way to open up the code editor and put it in there using only the mouse, because my mouse has been hijacked from me. I cannot. Haha, wonderful. Okay. Ha! You're wonderful. Thank you. Thank you, Naomi. Well, anyway, as you can see here, it's got all this stuff already in there. So this is all the stuff we just spent all that time. Oh, Mitchell? Oh, it's Mitchell. Oh, jeez. Okay, sorry. Oh, man, that's happened before. I apologize. Okay, it's Mitchell. I will endeavor to remember that. Anyway, this is all identical code to what we have what I typed in painstakingly manually in the other thing. It's just, it's got comments as well. Obviously, comments are just bits of code that aren't seen by the computer, so they're a way for you to write notes to yourself while you're writing the code, as you're writing the code, about yourself, about, your general thought process, about, how the coffee was that morning, whatever's useful for you. Make sure it's useful, obviously, but whatever's useful for you. Um, so that in case somebody else reads it or you come and read it 6 months later, you know what you were trying to do there. So let me go ahead and I'll start the simulation, and it's blinking, just like the prophecies foretold. And there you go. We've just created our first program and first circuit that blinks. Pretty wild, right? Or, not. I mean, I ain't gonna judge. This might be old hat for you. But trust me, this stuff will start getting more involved as we get along. This is just to get your feet wet, to get an idea of how the hardware and the software interact with an Arduino. They're both, by and large, equal parts. Now, granted, you could have some very complex software, and all it does is make a light blink, so you're going to have a very simple circuit. You could have a very complex circuit, and all the Arduino is doing is looking for a single input and directing either in one direction or another. So you could have some very simple code. But, by and large, you're going to have, well, you're going to have a largely equal amount of coding knowledge and electronics knowledge to be able to really enjoy the Arduino. As a single hobby user. Doesn't mean you have to be just a freaking wizard at both of them. That's not necessary. But being able to understand what you're doing, well, yeah, I'd say that's necessary. Being familiar enough with the coding aspect to go like, oh, okay, like I see what he's trying to do here. He's trying to create a custom function and call it and, pass in some variables and stuff like that. Eventually you'll get to that point, and that will be a useful thing to have. Being comfortable enough with how electronics work to be like, oh, I need to plug this in this way, and also I need to make sure to put a resistor here so that I don't blow up this LED or fry this IC. Well, you're going to need that too. So this is but the first step on a long and eventful journey to becoming very familiar with Arduino. If you find it interesting, I implore you, after Science Olympiad is over, to pursue it, to make stuff. People do cool stuff with these things. People make these weird light shows that hook up to the computer and then are used as like a health bar for games and stuff like that. People make little robots that, feed their cat whenever their cat brings back some RFID balls, and they hide the balls around the house. So, the cat has to go hunting in order to eat. Yeah, people do all sorts of stuff with Arduinos. Really, really and truly, I've said this a million times already, but I'll say it again. Your imagination is the limit. So hopefully you guys will get a better idea of what the Arduino can do and what it's like in the coming weeks. I'm fairly confident that you guys will knock the Science Olympiad out of the park, no problem. But if you're interested in it afterwards, I really encourage you to pursue it. Anyway, that's going to do it. It was a little bit shorter than I was anticipating, but we don't really have enough time in order to start covering a new concept today, unfortunately. Like I said before, normally I'd be asking the poll questions, but since, like I said, my mouse is being held hostage, I'm not going to be able to do that today. I can still see the questions pop up, so provided they're not too long and they are longer than, like a screen, I can read them and answer them. Otherwise, if you don't have any questions, you're more than welcome to head out and have a wonderful weekend, and we will see you on Tuesday with a new lesson on Arduino. More complicated lesson on Arduino. Well, it's going to involve more than one LED, but there's useful stuff in there too. No problem, Jacob. Thank you. No problem, Jim. Thank you. See you next Tuesday, Mitchell. No problem. See you next week. Nathaniel? Again, it's kind of cut off, so I'm not really sure. I see the first three letters. All right, excellent. Yeah, see you next week then. Thank you. Anybody have any questions about anything? Okay. Well, otherwise, everybody else, you have a wonderful weekend. See you on Tuesday. Same bat time, same bat channel. Take it easy, everyone. Whoops. Maybe. Okay. Doesn't want to start on its own. I see its game.